So whenever we study population growths, one of the big things that we started noticing is some commonalities between certain types of animals and how they all reproduce and their kind of life strategy, and then how that differs from other animals and their life strategy and how they reproduce. And so we started coming up with this concept of survivorship curves. When we graph them out, what's the likelihood of them going to survive to be older? And we started, like I said, just noticing some differences. And so we consider that to be three major types: type 1, type 2, and type 3. We'll kind of figure out which one we are here in a moment. And so there's different life histories that animals will have. And for example, if you're type 1, you're an opportunistic species. And we often call that an R-select species. So what's the characteristic of an R-select species? What is type 1 survivorship curve? It simply means that you usually live in environments that are relatively unstable, that they're constantly changing. And so it's difficult to live there. Things that have like extreme weather condition changes from day to day, like South Mississippi, just harsh daytime to nighttime cycles, maybe just a lot of predators in the area, things that are just not the best places, where things would be hard to live. In those cases, they usually have what we call a high fecundity, which means they just have many offspring, as many as possible. And because they're having as many as possible, they're often pretty small. And then very little parental care is given to those. That contrasts between the other extreme, which is type 3, type 3 survivorship curves, which in that case we call them equilibrium select species or K-select species. Those live in more or less stable environments. The weather may change, but not as often. It's not as drastic. They usually have a low fecundity, which means they have very few births, but the offspring that they do have are usually larger and smaller in number. And then they give a lot of parental care to those offspring. So I'll give you some examples. An elephant, birds, and mice. Well, let's start with mice. Mice have a large litter of offspring. The offspring are really small, and they don't give a lot of parental care to that offspring. And they usually have a high fecundity. They give birth very often to large litters. If you stir up a mouse in its nest and there's tons of babies, is that mother mouse going to hang back and defend its offspring? No, it's going to bolt because it can have just as many in a month. That's an opportunistic species, so that would be a type 1 survivorship curve, and we would call that an R-select species. Easy way to remember, R for rats. If you were to graph that out, 100% of the births, this is 10%, and then down here is 1, so this is a logarithmic scale, 1, 10, and 100. So very quickly, we see 100% of the babies being born, and instantly, within just a small amount of time, 90% of the babies are dead. Baby mice don't have that great of a chance of surviving. Their strategy to keep the species alive is just have as many as possible and just let the sheer numbers overwhelm everything, and that's how our species is going to live from generation to generation and keep going. Very rarely do we see old mice. Mice are eaten by a lot of things. They're a good food source. I mean, whenever I used to have a pet snake in my classroom when I was teaching high school, and we fed it pinkies all the time. Snakes love these guys. So, that's one strategy. The other strategy would be like elephants. Elephants live in environments that are more or less stable. Maybe not the best conditions, but more or less stable. They have a wet season and a dry season, and that's it. And so they instead of having a lot of babies, they focus on having just one, maybe two, but usually just one, and after usually like a 24-month gestation period. So you've already pumped a lot of time and effort into that one offspring. They give a lot of care to their offspring. If you start messing with a baby elephant, the whole pack, the whole herd is going to come at you, full blazing. You don't want to do that because that's how they make sure their species survives. They take really good care of that one offspring, and they all pull together to do that. Songbirds are kind of halfway in between. They're type 2. It means just at any point in time, they're just as likely to die. They give they have an okay number. They give some parental care. And at any point in time, they could die. over the course of their lives. Definitely not going to live forever, right? So nothing lives forever. So eventually they're going to die, but just when. With rats, it was pretty early in life they're most likely going to die. With elephants, it's the opposite. They tend to have a better chance of surviving because of all the parental care that they get. And songbirds are just halfway in between. So which one are we? Do we have 20, 30 babies at a time? Hopefully not, right? No, we don't. We generally have 1 or 2 offspring, right? And we give a lot of parental care to them. What about cats and dogs? They have larger litters, right? They don't have as many as a mouse, but they definitely have more than humans and elephants. And at any point in time, they do give parental care up to a certain point. So they're more like a type 2 select species. So after we started collecting data about the populations, we started noticing these life history patterns. And so we've been able to identify a lot of them and how they live and see that there's different strategies for different areas. Yay, science, right? That helps us manage their species. So what about human populations? So whenever we look at human populations, because again, like I said earlier, our numbers are growing, right? We look at birth rates and we look at death rates, right? What's coming into the population, that's gross, but what's coming into the population and what's going out of the population. That's going to be really important for us to know, right? We want to also know what's the total fertility rate. So who is giving birth and how many kids are they having? We also want to know like gender, how many males and how many females. That's going to affect populations. And we use all of this, and also how many old and how many young, because that also affects a population. And we use this data to graph out how populations change, and we usually do it by geopolitical differences of different countries. And we can see that, in some countries it's expanding rapidly. So here on these graphs we have ages that are younger down here on the bottom. The red is pre-reproductive ages, and these are done in 15-year bars. So 5-year bars. So 5, 10, 15. This would be the reproductive age in the yellow, and then the post-reproductive age is in blue. So we can see that for these countries, Guatemala, Nigeria, Saudi Arabia, they're expanding rapidly. They're having a lot of births, and it's getting larger every single year. So their population is growing, it's expanding rapidly. And we can also see, if we looked at ages compared to the other countries, they're not living quite as long. The average age is down a lot, because see, these numbers are a lot lower than the ones over here. So life expectancy in this country is not all that high. You're more likely to die off pretty quickly once you get hit a certain age. What about other countries like the United States and Australia and China? Well, they're expanding because they're getting bigger every single year, but they're not expanding as quickly. So this is a slow expansion. If you look at the top, I like to point this out because remember, the differences in males and females is also recorded. So these are the males, these are the females. If you look, it's more likely that females are going to live to be older than males, because the bars for the females are larger on this side than they are on this side. And that has to do with a whole thing called the grandmother hypothesis, which you can Google and look up and find information about why grandmothers are more important to a village and community than grandfathers are. But what about places like Japan, Italy, and Greece? Their population, it's growing a little bit, but more or less it's staying kind of stable. The numbers aren't really changing that much from generation to generation. So the numbers are starting to stabilize. And then in places like Germany, Bulgaria, and Russia, you have declining populations where there's fewer births every year than the previous year. And the population is starting to go down. A lot of that can be because of all types of different reasons, economic reasons, political reasons, environmental reasons. All of those things contribute to the decline in these populations. But we can, we measure all of this. We take in this data. I pointed out gender number and why that's important, and I think most people know that there's so many people and the population is so high in a lot of the countries that are in the East, like China, India, Japan, Indonesia. The populations are growing so fast there that they've reached and passed a lot of their carrying capacity. And so a lot of government agencies are going through and saying, look, we've got to manage our populations because we're all going to starve to death if we don't. There's just too many of us. And so they've put in some restrictions in some areas where families are allowed to only have one offspring. You can have more, but you have to pay a penalty for it. And in a lot of cases, their culture kind of suggests that they should have the male because they help carry on the family name and legacy. And so what happens when you have a female? Well, you have some options. You can either, if you know early enough, you can have it aborted. The other options are go ahead and give birth to it and give it up for adoption. Or the third is go ahead and give birth to it and keep it. If that's your first offspring, then you have a female, and that's it. If it's your second offspring, you're going to keep it, just pay the penalty. So what has happened is a lot of baby girls from that area of the world are actually being put up for adoption. If you've never heard about this before, it's a real thing. Look it up. If you've ever seen the TV show A Modern Family, a lot of people tell me I look like one of the guys on there, and it's a gay couple, and they have they have adopted a little girl, and she's Asian, and that's why the market is kind of inundated with little girls from that area of the world, simply because of cultural things that are being applied because of government population controls, because there's just too many of them. And, that's reality, and that is logistically things that have to be taken into consideration so that way the next couple of generations don't starve to death because there's just too many of them. Here's a little graph of human population growth over time. Some questions may pop up on your exam dealing with this. I don't expect you to memorize the information because the information's here. If I put this graph up, I would just ask questions about it. So it's not, did you memorize this information? It's just, can you read a graph? So over here on the side, we have the population numbers, and these are in billions, right? Across the bottom, we have years, or I have time, and it's time in years. Here's the AD/BC mark for 2,000 years ago, and you can follow our population growth and how it's grew slowly, and then we have these big expansions and die-offs, and then another big expansion and a die-off. And then we enter into kind of like the modern time, and we have the exponential growth, right? Exponential growth. Our carrying capacity is already been met and exceeded. If we didn't genetically modify a lot of our food that we have today, we wouldn't have enough of it in higher quality and quantity of food. We wouldn't be able to feed a lot of people on the planet. And in some places, food is a very much limited resource. But questions like, at what point in time did the human population reach 1 billion? Well, you would follow this line over time, and you look to see where does it hit the 1 billion mark. Well, here's the 1 billion mark. Here's the point in time. This is modern day. This is about 1,000 years ago. And I would give you options on the exam. And you'd probably say, hey, about 250 years ago, or about 200 years ago, we actually hit that 1 billion mark. So I like to leave you with this thought. There are more people living inside of this circle than there are outside of this circle. Let that sink in. There are more people here in this circle than there are outside of this circle. If everyone in North America, Central America, South America, Africa, Arabian Peninsula, Europe, Russia, and Australia, and New Zealand, down here in Papua New Guinea, if they all were to die, it's a morbid thought, yes, but if every person in those locations were to drop dead right now, over half the human population of the planet would still be doing fine. Our species would still survive. There's just so many of us, but most humans live within this circle. Weird thought to think about. There are 1 billion people in China. There's only 350 million in America. They outnumber us 100 to 1. So, just food for thought. And I'll see you next time. Bye.